is a module builder. How many people use Node or NPM or any of those tools? How many people have used something like Browserify? Any weird roll-up users or System.js? Oh, we got one cool guy. So, what a module bundler is it's modules. What's a module? So, if you're not familiar, anytime you've used a script tag, that is essentially a module. A module is an isolated unit of code that you can use in other contexts, such as a function that you use a lot. It does some common task, or an object, or an instance of an object. And module bundling is taking those modules of code and bundling them together, so you don't have to include, like 10,000 script tags or something like that. Cool. Hello? Okay. Okay, hopefully this is better. So, what Webpack does is, it's a particular type of bundler where it's not limited to solely just JavaScript. It's actually a bundler of many different types of modules. And it does that via a loader system. So basically, it's able to interpret, and the kind of graph I got here of JavaScript files, Jade files, CSS, LESS, thing files, whatever. It's able to interpret them and bundle them intelligently and produce a single file or multiple files that is the coalescence of all that stuff. So usually when you're writing an app, especially if it's something that's non-trivial, you're going to have one team working on one section of the app, and some other people working on other sections. You have designers working on CSS, and some guys working on images. It's a way to bring all that stuff together in a way where you can easily distribute it out to your end user. And like I mentioned, there are tools like this before, but most of them have been focused on the pure JavaScript world. So Browserify is kind of the same thing, but for the JavaScript-only kind of environment. So yeah, I want to show you guys stuff more than I want to talk about it, because I'm not so good. I got to build it. So probably just best to get started with things. So what I've got here is some basic code, and it's doing a require statement here at the top, which, if you're familiar with Node, this is what's called CommonJS. It's a method of obtaining other modules from elsewhere in the system and bringing them in, and it's the underpinnings of Webpack, at least Webpack 1.0. 2.0 actually supports ES6 modules and some other cool stuff, but that's some data. So what I'm doing here is I'm pulling in a module called lols.js. I'm randomly picking one of the entries from it and then console logging it out. So what does the lols look like? It's just a graph of funny, or it's an array of funny jokes I've collected over the years. So what I'm doing here is I'm establishing one module, which this is purely just an array. This could be a function, it could be something much more elaborate, it could be a React component, an Angular component, it could be anything basically. And the way it gets out of its environment is to use the module API. So this is another CommonJS feature where you have module dot, in this case, exports. So it's similar to how in the browser you have window. So window is your global that defines the very top level of everything. The module is the equivalent within the node world, and it's one global way to communicate with whatever is using this thing. We'll see some other uses for it later on, but the primary use right now is to define what you're exporting out of this. One interesting thing is, because you notice it's named plurally, it's module.exports, meaning you can actually export more than one thing out of a module and then include that into another thing. So you have a whole library of functions included in that, export them out as, say, an object and identify them by keys. So what I've got here is, again, just this file, and I need to build it. So the very basic usage of this is to just go into Webpack, go into this directory, and then just using the basic CLI of Webpack is it's harder to handle. It's like I just need the 7th path. By the way, all the code will be available at this address, and I'll show you links and stuff afterwards. So I have an entry file, and I'm going to send it out to something, so I'm just calling it bundle in this case. And so that's the basics of Webpack's CLIs. Give me an input file and an output file. The entry file is where your code starts. So you've got this whole group of bits of code that do things. You need to know where you actually get going. So that's why I've created an entry file, which is the first thing that will be executed, and then we'll requiring whatever it needs, do whatever stuff it needs to do, and then we'll exit at that point. So bundle, real quick. You can see what it's done here is shown that it's used both the entry file and then required in the lols.js, and took 2 milliseconds, and it produced a bundle that is 2.54 kilobytes. That's kind of big, considering these two sizes don't add up to that. Let's see what it actually just did. So if I look at the bundle file, you see all this nonsense at the top. And then down here below is where my actual code lives. And you can see each one is wrapped in a function that is inside of an array that's called from this other function. And you can see my require statement, which was just a plain require, has been rewritten to be a _Webpack _require file, which is requiring 1. So in this case, the module is identified by a number based on when it was put into the order that it was put into based on when it was ordered. So this is all kind of abstracted away from you in the long run, but it's good for us to look through what's going on. And then here's where like the meat of it's actually happening. So it's defining a whole bunch of setup code to actually make all this stuff happen. So we define the Webpack require function and which module ID we want to load. We check if it's already been cached and been loaded. If not, then we get that module by ID and call it. And we call it with module as one of its main inputs and module exports. And you'll notice that matches up with the function that's wrapped around here. So module and exports are provided into it. So that's how it gets to that instance of the module variable. And then just marks as loaded and returns the actual export itself. So what that's all doing in a long roundabout way is it's saying when I call Webpack require of 1, it's going to call out to this function and give me back whatever was set on module.exports. So I've got a little index file where I just included the bundle.js file, and then if I open that up, I don't see anything but console and make that bigger. I get a bunch of randomized. So these things come in and it's just picking one at random and doing what it's supposed to do. So pretty simple. I mean, when you actually boil it down, it's really just taking 2 files and mashing them together and giving you a way of accessing the other file from one file, or one module from the other module. That's not really the cool part. It's just kind of getting you going. What's cool is when you start to use the functions of Webpack. So one that, like I mentioned before, one of Webpack's key features is its loader system. So loaders let you do really cool stuff. They basically sit in front of the require statement and let you modify how that file is required. So in this case, I've got a very simple one of a build time, which is just going to give me a date back to a string, so a simple export. And then I'm just going to grab that, require it, and then print out on the console when this file is built. Now, if I do that, it's going to evaluate this code every single time fresh. So let me just quickly get this. So notice the time is continually going up as I refresh this. That's not constant. I was intending to have this stored to a string and continually produce the same output. How could I do that? Do that via loader. There's a really simple one. It's called toString, which you can inject into the require statement ahead of it, separated by an exclamation point. You can actually chain these things together. It's really cool. You can actually use the loaders to load up CSS that's processed through like Sass or PostCSS or anything. You can do it with images and use those images and have them be resized on the fly. All this crazy stuff that you can do via these loaders. This toString one, all it does is instead of building and just giving me the same output that was in the file, it's actually going to evaluate the file and put that as the output that goes into the build file and comes out of that module. So if now that I have this format, and I build it again, okay, it was 45 seconds. It's not increasing. And that's because it is now this time in the bundle. You can see it's actually printed out to a string, the evaluation of it. So this is a very simple loader. Probably won't use this one in practice. There are much cooler loaders that I'll get to in a sec. But that's the basics of it. Is it's allowing you to transform the stuff you're requiring in, not just blanket requiring stuff in. So let's see. So we have this command line to do this sort of thing, but this isn't really super expressive. When you want to do like automatic adding of loaders and stuff like that, it's not so fun. It's basically, this is good for bare bones stuff, but when you're actually going to production, you need some way to configure it on a larger scale. So it includes by default support for a Webpack config file. So this is plain JavaScript, it's not JSON or anything. So you can actually do stuff like, I'm just going through dir name, but the basics of it is I can define my entry file, which can actually be more than one entry file. Where I want to output to, which in this case I want to output to the directory I'm in and with the file name bundle.js. And then what I've done here is I've set up a loader that will process automatically on that require based on the tests that I've provided. So a common thing you'll see people do is they'll just do star.js. That's to have the any JavaScript file be processed by this. There's a very common one called Babel. It's a transpiler from ES6 down to ES5, and you usually want to write everything in ES6, so you'll run that loader on every single JavaScript file. In this case, I'm doing it on just the build time file. There's also some other options to change it. But the result is that it automatically looks for this file when it runs. So if you run it with no input, it'll just find it and build it. So I didn't have to do anything. I didn't have to specify where stuff was. It also hides a lot of the kind of stuff you don't have to see. And it produces much the same output as before of having the constant string. So it's a configurable thing. Some people don't like the whole, give me a giant object for configuration. It's kind of Brent style. If you're more of a gulp style person that likes, imperative instructional commands you can run, not a big thing. But I'm actually working on a project to kind of turn that into gulp style stuff for another project I'm working on. But that unfortunately is just what it is. So yeah, what can we do with really cool loaders? Now we got. So like I mentioned, we can use the Babel loader. Babel is again a really popular project to convert modern JavaScript into JavaScript that will actually run in the browsers you want to run in, which are all running ES5. So it can support ES 2015, React, and JSX syntax. It does some really cool stuff with like really experimental stuff like decorators and all that stuff. And it's all pluggable, which is really nice. So you can add the stuff in progressively as you want. But what I'm doing here is I'm adding a little bit more of the feature set that we can use for Webpack. This is all, again, accessible via the CLI, but it's really terrible to use via the CLI, so it takes a lot too much right now. So at the top, I've added, first thing you'll notice is different, is a dev tool, source map. That means this is going to be I need a developer tooling to go along with this. I need what's called a source map file. So if you're not familiar with what those are, if you've got like any other transpiled language, CoffeeScript, PostScript, any of those things, when you get the resultant JavaScript, it's going to be this hunk of stuff that isn't what you kind of were expecting. And you need a way to actually interpret when something goes wrong in that real JavaScript code back in your, whatever code you wrote. And the source map does that. It maps the actual executed JavaScript back to what the source was. So you can see it as the pretty ES6 or ClosScript or CoffeeScript that you wrote in the DevTools within Chrome, Firefox, all of them, without having to hunt around and figure out like what produced what. I'm also using, you can see the Babel loaders in there, and then I'm using some plugins for optimization. So that's a common thing you want to do. It comes bundled in with Uglify, which if you're not familiar is a compressor of JavaScript. It takes really big JavaScript and makes it really small JavaScript. I'm using one called Order Occurrence Plugin, which just makes it consistent in how it builds. So the module order will be the same every single time, and you don't have to worry about things getting out of order. And then I'm using Define Plugin, which is letting me, this is a little trick to add stuff for, I'm going to show you a little React code. React has a toggle mode between a development build and production build based on process.env.nodeenv equaling production or equaling development. If it equals production, then it turns off a whole bunch of code, gets rid of a whole bunch of code, produces a smaller build, a faster build. It's a common thing in the Node ecosystem to use this as your flag for whether or not you should have this code existing at all. And Uglify.js will notice that, and it'll say that you'll have code that will read, basically does production equal development, and that's obviously not true. So it will see whatever's inside that if block as dead code and will just wipe it out. So you get rid of a whole lot of code that way really fast. And again, just to show you the app I'm building really quickly, it is just a standard ES6 style React app. If you're not familiar with this, don't worry too much. Basically, import is the same thing as var react equals require react. And render is just var render equals require react DOM dot render. And then there's some JSX in there. Again, don't worry too much about it, but the point is to show that we can write our code however we want. We don't have to think about the build process or how it gets to the browser. It works. And then for my app, it's just a very simple component that just prints out hello world. I have a Babel RC file that configure Babel, which if you're familiar with, you're asking about that. And then the index file is just the same as always. I've just added a root file. That's a React thing where you need to tell it where to put this stuff on the page. So, I'll go over to 4. Build that. And you can see it took a lot longer. It's because Uglify is pretty slow, but it's something you only can run in production, so it's really not a big thing. Our bundle size is obviously much larger now. It's 132 kilobytes. But we've got this bundle.js.map file, and that's the source map. And that's huge, but it's a separate file. So people aren't normally going to run into it unless they open up DevTools on their site and they really want to poke around in source code. You don't have to ship that if you don't want, but it is there for you if you want to use it. And then, yeah, I've got this showing up on the page. And then if I open up the JavaScript console, go to source. It won't work in the file mode. But Unfortunately, I need to actually have this running a server. I think I'll be able to show it later, but there would be source maps there. And then this is, again, what the output kind of looks like. This is compressed code, you can see, except for the comments that were in there, which I assume are license kind of stuff from Organizer. You can see the source mapping URL so that your browser knows where to grab the source map file from. But it's not included in this file, it's something entirely separate. There's a separate mode where we can actually inline it into the file, which is kind of cool. Let's go through. So, I'm going to see if we're this one. No, I'm going to skip this one. Clearly wasn't thinking. Alright, well, let's skip it. So, one thing you'll commonly want to do is obviously running these files, loading these files up as files in your browser with this file URL in there limits some of the stuff you can do with it. Your browser has certain service security restrictions on that, and it's not real like a web server. So Webpack has a very simple web server called Webpack Dev Server that embeds Webpack within it, auto reloads and compiles your code on the fly, and then provides it in memory back to you over the browser. And you can do really cool stuff where you can actually load that code up dynamically. So this is probably one of the most powerful features of Webpack that people use on a regular basis. It's called hot module reloading. So we've got all these modules, we're pulling them in via requires. What if we could do that whenever the file changed? Just tell the browser, hey, I've got a new copy of this module, load it up. So that's what hot module loading lets you do. Is it lets you say, I've got this module here that does counting, just a simple counter, and I've got an entry file that wants to load it, and I'm just setting an interval, and every second printing out the output of that. Now what I'm using here is another feature of the module API, where it's an extension that Webpack provides, where I'm able to say, I'm willing to accept any changes to the counter file. And if you do that, then I want to run this code. So whenever there's a change, give it to me, and I will re-require counter. It's now updated in memory. And I want to set it to the function that I'm using. So I can basically so this is the dev server. It's very simple. It kind of looks a lot like an Express app if you've ever written anything like that, or just plain HTTP. It's configurable that way. You can run it on the command line, but I like to run it this way. And just set it up so it will load up the hot module loading stuff for me. So if I kick that off, so you can see it's actually built up all this stuff inside of there. A lot of that is for the hot module loading. And then if I I don't know what the it's trying to find it. You can see I'm printing out this thing that's just printing out one number every second. So if I change this code in real time, keep an eye on this if you can. Let's just make that 10. You can see it hot reloaded the code. So it got an update from the server. It told it, hey, I've got some code for you. Load this. Loaded up the module. The updated module is number 77. And you can see now it's incrementing by 10 each time, completely on the fly. This is, again, probably one of the cooler features of Webpack is that you can, as you're coding live reload stuff, it works completely automatically for things like CSS or images. So like that hot module.hot.accept code, you don't need to write that for anything like that. So it's really, really fast if you're doing like say a style guide or something. You want to just quickly iterate on something you're typing up in CSS. You can instantly see the results on your screen. There are also projects like React Transform that will hook into this and will do things like this for React components. where if you're like moving stuff around or you're rearranging a few things in your component structure, you can have it automatically show up on the screen in real time, which is, again, really powerful stuff. So, so another cool feature of Webpack is the ability to provide, it does a thing called chunking. So you've got all these modules, and they group up together into logical groups. In this case, I've got a public area of my site, I've got an administrative area of my site, and they both use React. So one's a React system, and the other's a React system, and they both use common things. So this is my public code where I'm just saying the abstraction is public, and this is pulling in React and DOM and the app component. Same thing for this, it's literally one word change. So there's a lot of common code here. If I'm going to build a setup for this, so let's imagine this is a much, much larger set of components and things like that. When I load up my admin interface, I don't want to load up all the public stuff. And vice versa, if I'm loading up my public version of my site, I don't need to load up all the admin junk. That's a lot of junk. So what you can do is you can split these things into chunks, and it will automatically find the intersection of those two things. So you've got this commons chunk plugin, which is a plugin that will find all the common things between these, the common requires, and put them into a single file. I'm calling it vendor in this case. If I build this, you'll see it's now building an admin file, a public file, but it's also building this vendor file, which is much, much bigger. Usually these will be a little bigger too. But I've got this common file that I can use along with these other guys separately. And I can separate out the bits of code that aren't important to load up right now. And then in something like my admin file, I can include the vendor code, and then I can include my admin code, and then vice versa for the public one. And what gets built is actually kind of interesting too. It's really small. Like the vendor code includes all that junk that was at the header of the build that we saw at the beginning. It's just another, it knows it's in another file, it knows it exists there, so it doesn't need to do all that stuff. So it's just going to call the little function that it knows exists, assuming you've set up your code. But yeah, that's a basic way of you being able to pull out all the vendor-y junk you don't need. It's also intelligent enough to know when you use something specifically in the admin area, like say you use jQuery in the admin area but don't use it in the public area, it knows enough to put that into just the admin file and not into the commons, things like that. And then lastly, and this is much longer than I thought it was, what we can do is, another really cool thing we can do is code splitting. So code splitting is saying, say again I've got this public site that has like, a bunch of different sections, like a calendar and a discussion board and newsfeed, things like that. I don't want to load all that up at once. I want to load that up progressively as I need it. And what you can do to do this is, there's a specific API for it called require ensure. And that says that I need to, I need this stuff, in order to run this code that's in here, I need these things. I need React and React DOM, and I need my, I don't need them at the beginning, so it's not going to build them in right away, but it will load them when I request them. And it'll say, it'll basically do all the work that's needed so that when this function is called, the inner function, you'll be able to run synchronously and load up and have everything available to it already. When this one builds, it's kind of easy. I think it's already built, so I'm just going to yeah, basically include my my app file like normal, but what comes out of it is a lot less. So I've got like this component and all this junk, and you'll notice I've got very little code here. Like this is none of the React junk that would be normally included, but it gets included on the fly. So I think this one looks. So again, you can notice that in the build file, the file I included, that component, it doesn't exist there. It loaded it up dynamically. It added it, it did use the script loader. So, actually did was, just to show you it getting added, I printed out the, what's in the head, basically, of the page. So the little child notes at the beginning, and then after I've run this. And you notice this new guy showed up. And that guy is the extra chunk file that I put in there. You can customize how these things come out, so it doesn't just have to be like 1.1 and 1.2, whatever. But it added it on the fly. So that's probably one of the more advanced things you can do, but it's really powerful when you start getting a really big app and you need to break it up and make it performant. You can just start ripping out stuff that isn't needed to be loaded initially. Another project I work on called React Router, we use this pretty extensively to let you dynamically load routes of your application. So you might have like a route, again, for that calendar or for that discussion board, and you dynamically load the components and the code needed to render that calendar versus rendering that discussion board, which might be two separate things. It might include the CSS as well. You might be separating all that stuff out. You can basically dynamically split these things out as needed. And what's really neat is you didn't even write any like special configuration for that stuff. Like there was nothing in the Webpack config to say like I must build chunks separately. You just define the file name with this brackets name thing, and it'll automatically do it for you. So in summary, that's kind of all the cool features I know out of Webpack. There were a lot of really cool loaders and stuff. I didn't even get into like loading CSS on the fly dynamically. That's probably more flashy, but yeah, that's basically it. So, do we do questions or anything? Yeah, Norman? You have any questions?
Does Webpack do everything that like Gulp would do? If not, can you integrate with them?
You can integrate the two of them. So Gulp is more of a task runner, and this is specifically like a bundler system. So it's very similar to how you might include browserify in your Gulp file. You can include Webpack as well. Generally, it's not done that way. I don't know, I just haven't seen that much use of it, because a lot of what you would use Gulp to run tasks for, those tasks are done by Webpack. So it kind of supersedes the whole ecosystem of Gulp tools that you kind of use to get.
Yeah, can you talk a little bit more about what it does with images? You talked a lot about CSS and JavaScript.
Yeah, so images, there's actually one plugin I didn't show that lets you take certain things and extract them out and write them as separate files. There's actually a plugin that does static site generation via this. It basically writes out a separate file itself for each of your static site pages. So pulling out content and putting it into a separate file is a very common thing to do. If you don't want to do that, and it's very common to do this in development, you'll actually load it as a data URL and base64 encode it on the fly, just put it in there, and then it becomes a JavaScript object you can reference just by its source URL. So you can say image source equals and then some JavaScript to print out the contents of whatever that requirement is. Either provide you a URL, and that will be a real URL to the file, or it'll provide you a data URL, which will be the base64 contents of that image file. It works for anything like that, including JSON files, any binary or non-binary file. It can include that way. Anything else? Yes.
Is it custom bundles that are any of the loaders? Can it do like that code elimination or tree shaking or anything?
So the code elimination that Uglify does is different from the code elimination that tree shaking enables. Tree shaking is, for those not familiar, so I had the, so I have this array here where I have import, React, and component. Let's just get rid of this. So I'm importing just the component, method, class, function, whatever it is, from the React module. I'm not importing any of the other stuff. So the idea is that if I can know that I'm just importing that one thing out of this file, I can get rid of all the other stuff that's not required by that file. and you can basically form this tree of dependencies and shake out the ones that are not connected to that tree at some point. So the other stuff that's included in there, if I did not include React at the top level, didn't include render or any of those stuff, that would be shaken out. And then it becomes easier for tools like Uglify to go through and remove those as dead code. They basically get marked as dead, and then Uglify comes up and cleans up everything and gets rid of it all. That's coming in Webpack 2, which is still in beta right now. I think it's in beta. And I don't know when the release date for that is, but there's another tool called Rollup, which has been doing that from the get-go, which you know, it's debatable which one's better or not. That one's more of a straight up just module builder. It doesn't have all these module loading or code splitting kind of functions that Webpack does. But I encourage you to check out the betas of Webpack 2 because it's, I mean, Zucker, the guy that makes it, is using Webpack code. So it's generally pretty stable stuff. It's just marked as beta. Any other questions?
Sorry to look this up ahead of time. Did you imply that the Webpack 2 does some transpiling of ES6 to something else?
No, that was via a loader,
Okay.
the Babel loader. So Babel is a separate project that can be loaded into and used to process anything that's required in there. Cool.